All right, in this video we are going to be still working with trigonometric functions. However, we are going to take a step back from the unit circle and look at more of the triangle application of trigonometric functions. So we're going to say this in 6.3 still. However, your book doesn't talk a ton about this. I'm going to call this trig ratios with triangles. And this is kind of how trig ratios, sort of the origin of trig ratios, is the triangular application of them. And you might have even seen this in Algebra 2, perhaps. So let's go ahead and dig in with just drawing a basic right triangle, like this. And we'll call the vertices of these A, B, and C, capital letters, such that the sides opposite of the large letters are the lowercase letters. So this is sort of the basic intro triangle that you would use to illustrate any of these trig ratios. All right, and then if you were asked to find, let's say, the sine of a particular angle, we could then use some facts. I like to start with this acronym called SOHCAHTOA. Hopefully at some point you've been exposed to that before. SOHCAHTOA is just an easy way to remember sine, cosine, and tangent. And how this works is, well, the sine represents the opposite over the hypotenuse. The cosine, the ka, represents cosine, which is adjacent over hypotenuse. And the toa represents the tangent, which is the opposite over the hypotenuse. So hopefully this isn't completely foreign to you. Definitely write it down, especially if you don't already know this, but write it down either way. So that, let's say we were asked to find the sine of angle A, so big A. Okay. Well, the sine of angle A, we would look to first the opposite. So opposite of angle A would be, well, little a. And then the hypotenuse is always going to be the side which is opposite of the right angle. It's always the longest side. So that would be a little b. So that would be the opposite of the hypotenuse. If we were to similarly ask the cosine of big A, well, we'd look to the adjacent side first. So in terms of big A, the adjacent side, adjacent sort of means next to, or the side touching it. So that either leaves you with C or B, because those are the two that sort of form angle A. However, B, that's always the hypotenuse side. So the adjacent side has got to be the other one, which is C. And then the hypotenuse would be B. And then if we were to ask to find the tangent of big A, that's the opposite. So the opposite of big A is little a. The adjacent side is little c. Now, in addition, we also had some other angles, some other trig ratios, and those were the inverses of these. So we had all of these sort of had a pair that went with them, right? So with sine, we had the cosecant angle. So cosecant, CSC, represents the sort of the inverse of sine, which means we flip this ratio. It is the hypotenuse over the opposite. Okay, and along with cosine, we had the inverse of that, which was secant, and that would be the opposite, hypotenuse over adjacent. And with a tangent, we had the cotangent, which is the hypotenuse over opposite. Oh, sorry, I messed up somewhere. This should be adjacent. Whoopsies. All right. Sorry about that, guys. So go back and correct that. Opposite over adjacent. I think I said adjacent, but I wrote hypotenuse. All right. So let me go ahead and, so this would be the adjacent over the opposite. All right. So there we've come up with our 6 ratios. And if we were to do the same thing down here as we did before, so with the sine, the opposite of that would be the cosecant of big A. Well, the cosecant is the hypotenuse over the opposite, or just flip the sign. So that's B over A. And then with the secant of A, that's the hypotenuse over the adjacent, so that'd be B over C. And with the cotangent of A, adjacent over opposite, C over A. So we come up with these 6 trigonometric functions or ratios, and those really describe the different possibilities we could have with any given angle. Now we could also take it from a different perspective. What if I asked the sine of angle C, for instance? So now this is the one we're focusing on. Okay, so the sine of C, the opposite over hypotenuse. So opposite of C is, big C is little c. And then hypotenuse was still B. So C over B. So it changes things a little bit. If I were to then find the cosecant of C, okay, that would just be flipping it, B over C. All right, if I were asked to find the cosine of big C, well, that would then be the adjacent. Now the adjacent side is A, right? And then the hypotenuse is still always the hypotenuse, so that's A over B. And then, of course, the secant of big C would then be B over A, so on and so forth. So that changes things a little bit. So we're going to use this table. And again, hopefully you have at least seen this at some point. We're going to be using this table and doing some exercises on Delta Math to help us practice using this table and these triangles as well. On the first couple exercises, we're just going to use these first 3. So I would definitely try to memorize this SOHCAHTOA, because if you memorize SOHCAHTOA, then you can get the first 3 trig angles. And then with the first 3, you can get the other 3 because they're just flipping them. So let's go ahead and take a look at the assignment here real quick. The first assignment is actually one of the timed ones. Don't worry too much about the clock because you'll have 300 seconds and it will definitely be doable. The key thing is make sure you get, don't miss any because you have to get 8 correct in a row. All right, so it's going to give you a triangle and it's going to ask you the cosine of the angle B. Okay. So I would write out SOHCAHTOA. That's really all you need. So then the cosine of B, well, here's B. Cosine is adjacent over hypotenuse, right? Cosine of B, adjacent. So adjacent to B is going to be 60, okay? Because this one is the hypotenuse, 68, because it is opposite of the right angle. So if that's the hypotenuse, then the other side that's connected to it has to be the adjacent. So adjacent would be 60, hypotenuse is 68. You would want to reduce this. However, for this activity, they don't make you reduce it. So we're just going to click 60 over 68. Okay, the next one, we're asked to find the sine of angle B. So just look over here. Sine is opposite over hypotenuse. So opposite of B is 45. Hypotenuse is always opposite the right angle there, so 51. It's 45 over 51. Okay, the next one, cosine of B. Should have done that. Adjacent over hypotenuse, so 40, this would be adjacent. Hypotenuse is 58. Adjacent over hypotenuse, so 40 over 58. All right, so this one's going to switch to A. So sine of A is opposite over hypotenuse, so opposite is 56. Hypotenuse is 65. So opposite over hypotenuse, 56 over 65. All right, so we continue this on. Sine of B, opposite over hypotenuse, 20 over 25. Cosine of A, adjacent over hypotenuse, 12 over 13. So we just continue this. And again, you've got 300 seconds to do this. It gets pretty easy after you do it a while. Tangent, opposite over adjacent, so 75 over 40. Sine of B, opposite over hypotenuse, 24 over 74. And you will get opposite over hypotenuse, 21 over 29. Just get the 10, opposite over adjacent for A, 42 over 40. Once you get your 10, then you can go ahead and stop. All right. The next one, going to be just a tad bit more challenging because we're going to have some radicals in here. And you have to think back how to simplify radicals. There is no timer, though, so that makes it a little easier. We're specifying the tangent of A in this one in the simplest radical form. So again, I would still write out SOHCAHTOA. Tangent of A is right here. Tangent is opposite over adjacent. So tan of A, opposite of A is 3, and adjacent of A would be 6. And this we should reduce because it's simplest. So that's just going to be 1/2. Okay, next one is the sine of A. So the sine is the opposite. So opposite of A is radical 63 over hypotenuse, which is 12. So radical 63 over 12. All right, now we do have to reach back into some of our knowledge on how to simplify radicals. So this, for some of you, will probably be the most difficult part. For these radicals simplifying, what we want to do is break this radical into something that we know is a perfect square. So we want to look for a perfect square inside of that radical. So I'll show you just one here, and then hopefully it refreshes your memory a little bit. So 63, we can break into 9 times 7. And the reason I'm choosing this instead of like 3 times 21 is because 9 is a perfect square, right? And then so what I do from there is I then sort of break this up into the square root of 9 times the square root of 7 over 12. And the square root of 9 is 3. So then I just simplify that to 3. So 3 radical 7 over 12. And then with that, I can actually reduce this sort of this fraction here. 3/12 reduces to 1/4. So this just becomes 1 radical 7 over 4, or just radical 7 over 4. So that is how you need to type it in, radical 7 over 4. Again, for many of you, that will probably be the most challenging part, is remembering how to do that. What I would suggest is making a little table, which I'll do here, and you can replicate it. And that is, first of all, just square root of 1 is 1, obviously. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. That should be all you need. So when we go to simplify these radicals, we're going to be looking for basically one of these numbers here. We're going to be looking for one of those to split it into. Okay, so let's go ahead and try the next one. The cosine of A. Here's A. Cosine is adjacent over hypotenuse. So adjacent is radical 75. And hypotenuse is 10. Okay, so we do need to simplify this. So I want to look at the square root of 75 and try to find one of these from this table that's in there. So what I do is just kind of start from the top. Try to find one that divides evenly. Just work my way down. So 100 doesn't go into it. 81 does not go into 75. 64 doesn't. 49 doesn't. 36 doesn't. However, 25 does. Bingo. 25 goes into 75. So then how we're going to write this is the square root of, we just think, well, 25 times what is 75? It's 25 times 3 over 10. And then we split this up into the square root of 25 times the square root of 3 over 10. And then the square root of 25 is 5, right, over here. So we get 5 radical 3 over 10. We then need to simplify the fraction. 5 over 10, that's 1/2. So it's just radical 3 over 2. And that is what we need to type in. All right. And that one's pretty easy. Same with that one. I want to find one more here. Some of them are quite easy. I wanted to see if there was any with a... All right, here we go. So the cosine of angle A would be the adjacent 4 over the hypotenuse radical 65. So this one has an added challenge of the fact that there's a radical in the bottom of a fraction, which we can never have. So the first thing that I'm actually going to do is multiply this by radical 65 over radical 65, because that is how we get rid of a radical in the denominator. So then we get 4 radical 65 over 65. Okay. Now let's go ahead and try to simplify that square root a bit. So let's think. Can any of these numbers go into 65? 100 can't go into it. Nope. 81, nope. 64, nope. 49. 36, nope. 25, can it go into 65? Nope. 16, does it go into 65? Nope. Does 9 go into 65? Nope. Does 4 go into 65? Nope. So that's actually it. The only one that goes into it is 1, which would be pointless. So that's actually the simplest radical form we can get. Okay, so that's easier. Now we have to think, can we simplify this fraction here in front? Does 4 go into 65? Well, no. So we actually are just going to leave this as 4 radical 65 over 65. Again, they all won't be this difficult. Some of them are quite easy. That's how you do it. Okay. I want to show you the last one here, and that is going to be using some of the other trig ratios. We should not need this square root table for this, but so again, I'm going to write out SOHCAHTOA, and this one is going to ask us some questions about secant, cosecant, and cotangent as well. All right, so in this one, we're supposed to find the cotangent of u. Okay, cotangent of u. So u is right here. So what I normally do is think, what does cotangent match with? Well, that matches with tangent, so TOA. So cotangent then would be the flip of the sort of the reciprocal of tangent. So that's going to be adjacent over opposite, because tangent is opposite over adjacent. It's a good idea to just write it out there. So the adjacent side of u then is 77, and the opposite of u is 36. So 77 over 36. I don't believe that can be simplified, because the only factors of 77 are 7 and 11. Those do not go into 36. So I believe we're good. All right, let's try another one, cosecant. So think about what cosecant matches with. Cosecant actually matches with sine. Again, as I mentioned before, it's kind of the opposite of what you'd think. You'd think that sine and secant go together and cosine and cosecant, but that is not the case. I was just telling myself it's the opposite of what you'd think is true. So cosecant goes with sine and secant goes with cosine. So it just flipped. All right, so we want the opposite of sine. So we want the cosecant, cosecant is the hypotenuse over the opposite. All right, and then we're talking about angle I. So angle I is here. The hypotenuse is 65, and opposite of angle I is 63. So 65 over 63. All right. If it was the sine, you just do the same thing we've been doing. Let's try to do. So let's do one more, secant of E. So secant, think about what that's the opposite of. It's the opposite of cosine. So secant is going to be the reciprocal, hypotenuse over adjacent. So the secant of E is there. Hypotenuse is 13. And adjacent to E would be 5. So 13 over 5. All right, so all three of these are really just to get you familiar with finding the trig ratios with triangles, and we'll build on this in the next lesson.